Welcome, class. Tonight we're going to learn about speed and velocity. And today we started taking these notes in class because I wanted to get you used to taking notes in 4 different colors. Remember, the colors are blue for definitions, black for units. Now, black on these videos will be white because I want to have a black background. And red will be for formulas, and green will be for examples. So today we started talking about a scalar. And remember, a scalar is a quantity that has no direction. So some examples of these would be time, temperature, distance, mass, and speed. For example, we would never say that it is 37 degrees Fahrenheit to the east. Okay, so there's no direction to temperature. Time always moves forward. Mass is how much matter there is in a substance. It doesn't have a direction. There are also quantities called vector quantities that have directions associated with them. And we have to be very careful when we solve for vector quantities because the direction is very important. And for the most part in our class, we're only going to talk about one dimension. So either forward or backward, positive or negative. We won't really be talking about 2 dimensions, which would include like north, south, east, and west. Some examples of vector quantities that we're going to be learning about in this class are velocity, force, and acceleration. And also you can add to this displacement, which we're going to learn about today. So let's go ahead and dive in. Distance is defined as the length of a movement, and it can be measured in meters, kilometers, centimeters, miles, and there are a lot of other units you could use, inches, feet, for example. We're going to pretty much use the metric system, so meters, kilometers, and centimeters. Now, displacement is different. So displacement is the change in position of an object, and the symbol for displacement is the Greek symbol delta. It looks like that triangle in front of the x. And the symbol x stands for position. So if x stands for position, and then delta x stands for change in position. You might remember that from your math or science class last year. So delta x would be our final position, x final, minus our initial position, x initial. So we can solve for displacement by taking the final position and subtracting the initial position. Let's look at an example. So here we have a bicyclist who is starting at 0 kilometers and is going to travel 2 kilometers in the positive direction, maybe going to the store to buy something at the store, and then traveling 3 kilometers back in the opposite direction, maybe going to a friend's house. So the first question is, what is the total distance traveled? So the total length of movements, we need to add those 2 together. What do we get? That's right, we get 5 kilometers. The student bicycled 2 kilometers to the store and then 3 kilometers back to his friend's house or her friend's house. So 5 total kilometers. Now, the question is, what is the displacement? Remember, that is the final position, right here at -1, minus the initial position, 0. What is -1 minus 0? That's right. The displacement is -1 kilometers. What does that mean? That means the bicyclist is 1 kilometer backward from its original position. And that makes sense. That's the displacement. Okay, let's learn a little bit about speed. You kind of already know about speed. You've all been in a car before, and the speedometer, which is a meter of speed, measures the speed the car is traveling in miles per hour. But you may not be as familiar with speed in other units. So we're going to be using the metric system. We're going to be using other units. Speed is basically how fast an object is moving. It's the distance traveled divided by the time it takes to travel that distance. So we have 2 units in our unit of speed. We have a unit of distance in the numerator, and we have a unit of time in the denominator. So miles per hour, and you should write these as miles and a horizontal fraction bar, an hour underneath. Same thing with kilometers per hour, horizontal fraction bar. I can't do that on the computer screen. All right, so you're familiar with speed, and I believe you solved for some speeds last year. What you may not be as familiar with is velocity. Velocity is speed, but also with a direction. It is a vector quantity. So velocity is sort of displacement over time. Our change in position over that time period. You can ignore this delta t on the bottom. It's just time. So our change in position over time. So let's go back and let's look at this original example. Let's say this bicyclist took a half an hour to make these two movements. So if we're going to solve for the average speed, we need to take the total distance and divide it by that time. Why don't you go ahead and solve that now? So what is the average speed of the bicyclist? You're going to take the 5 kilometers that the bicyclist traveled and divide by half an hour. 5 divided by a half an hour gives you a speed of 10 kilometers per hour. Okay? Now let's look at what is the average velocity. Now remember, velocity has a direction. So we're going to have to keep this in mind. We have to think about where are we from where we began and divide that by time. So displacement divided by time. Remember, displacement was -1 kilometer. We went 2 kilometers forward, 3 kilometers backward. We were -1 kilometer from where we started. So we're going to divide that by half an hour. -1 divided by a half of an hour gives you an average velocity of, that's right, -2 kilometers per hour. So what you should have learned from this lesson is speed and distance are scalar quantities. Displacement and velocity are vector quantities. Furthermore, you should understand how to calculate speed and velocity. Speed is just total distance over time. Velocity is displacement over time, a little bit more complicated. And displacement is our change in position, our final position minus our initial position. We're going to learn more about this in class tomorrow. I look forward to seeing you then.